Okay, class, today we're going to learn about density. Now, density, we're kind of looking at the heaviness of something when compared to volume. So you have a constant volume, how heavy is it? So is something going to sink or float in another substance? So think about water. If you throw a rock in water, does it sink or does it float? Okay, when we're looking at that, we're looking at density. And the answer is that it sinks, right? So the next question is it more or less dense? If it sinks, then it is more dense. If it floats, so for example, oil floats on water, so it's less dense. And this comes in play, I'll show you here in a minute why this is important. But first, let's get calculations. Here we go. I'm trying a new program here. Hopefully this works well for you guys. The formula for density equals to mass over volume. Okay, now typically when we're looking at units, your mass is going to be in grams and your volume tends to be in milliliters. Now there's different units, you can use any volume and any mass, but that's the most common, I would say, grams per milliliter. So if we look at this, if we have density, if the mass is in grams and the volume is in milliliters, just plug it into this formula here. So the density is grams per milliliter. Anyway, so the weight per volume. Okay, so let's look at some calculations. Let's say that density, let's say density equals to 2 grams per milliliter, okay? And we know the volume of whatever substance this is equals to 10 milliliters, okay? And then I can ask you, what is the mass? Okay, well, let's look at our formula here. We have a density, we have a mass, and a volume, and let's just plug it all in, okay? We know density is 2, and also look at the units where we do this. Do you see that in density I use a milliliter right here? And my volume is in milliliters. Those units have to be the same. The volume units have to be the same, and if I had a mass, the mass units have to be the same. And I'll show you where they're different. But let's do an easier one first. So let's plug it into our formula. So here's our formula. Density equals to mass per volume. So we have density, we know equals to 2. So we have 2 equals to our mass. We don't know our mass, so I'm just going to put an M. And our volume, I said equals to 10. Okay? So let's figure this out. 2 and M. Now, we want to isolate M, so what we do is we move this over. It's divided here, so we move this over to there. We're going to multiply. Okay? So we have 2 multiplied by 10 equals to mass. So our mass equals to 20 grams. Now if you look here, milliliters is the same, so what unit is not the same? Grams, so that one won't cancel out. So let me show you with a unit conversion, because that's what we've been doing, what that would look like. Let me see if I could just delete this. Yes. Okay, so with the unit conversion, you always start with, so let me put our units up here. We know that we have a, oops, I didn't switch. Okay, so we know we have density equals to 2 grams per milliliter, and we know that our milliliter, our volume equals to 10 milliliters. So with unit conversions, you're going to do it like this. You always start with the most simple units. So basically the unit that's just 1 unit. Do you see that this one is a gram per milliliter, so that's 2 units, and this one is 1 unit, only a milliliter, so we'll use that one first. So we have over here 10 milliliters, okay, and we want to convert to grams. Now let's look here. We have a milliliter up here, so we want to cancel it out because our final answer is not in milliliters. So what do we put down here? Milliliters. So we put a milliliter. And look what we have here. Density we have equals to 2 grams per milliliter. So we know for every 2 grams, we have a milliliter. Do you see gram per milliliter? Do you see the 2 is with the grams? The 2 is not down here with the milliliters when I draw it. I don't draw it as a gram per 2 milliliters. It's a 2 grams per milliliters. That's why the 2 is up here. Now let's look at our units. Our units will now cancel out. Milliliter, milliliter cancels, leaving only grams. So we have a 20 grams. So that's how you can see. It's another way of looking at it. Instead of plugging into the formula, you just do unit conversion. Okay, let's look at another one. Okay, so let's say we have our mass. Let's say our mass is 4 grams. And let's say our volume is 0.5 liters. Okay? And I want density in grams per milliliter. Okay, now let's look. Grams and grams, that's the same. So there's no conversion I need to do there. But look at this, milliliter and liter. That's not the same. I have to have them in the same unit. So I need to convert, before I can do anything, my volume into milliliters. So I have 0.5 liters. I'm going to put my liters down here because I want to cancel it out. And if you look at your conversions, there are 1,000 milliliters per 1 liter. So if I multiply this out, put it in my calculator if you want, you're going to get 500 milliliters. Okay, so now my volume is, instead of saying 0.5 liters, it is now, we're going to say it's 500 milliliters. Okay, so now milliliters and milliliters, all the units have to be the same. They are the same. Okay, so now let's look at my formula. My formula says I need a gram per liter. So I know I have 4 grams. Okay, so let's plug that in. I have 4 grams. Okay, and I want to put that over milliliters. So I have 500 milliliters. So you see my units are in grams per milliliter. So this will give me density. I'm going to put density equals 2. When I divide these two, put it in the calculator, you get 0.008 grams per milliliter. Okay, so I hope that helps. So there's different ways when you're looking at density. Since the density formula is density equals to mass per volume, I can literally ask you to calculate the mass, and that way I'll give you the density and the volume. I can ask you to calculate the volume, where I give you the density and the mass, or I can ask you to calculate density, and I give you the mass and the volume. So basically, I have to give you 2 of these numbers, and you have to figure out the third one. Okay, so we'll have homework problems that go over that. The biggest thing is make sure all your units are the same. So do you see where you have a gram? Make sure it's in grams and not milligrams or kilograms. If you have milliliters, make sure all of your volumes are in milliliters. The last thing I want to go over with this lecture is just over kind of measurements, like precision of measurements and everything. So let me pull up this slide over here. See if I can drag this picture onto here. I haven't tried this yet. Drag. Nope, it doesn't want me to drag. So we'll just pull it up here. That's okay. This is the difference between precision and accuracy. I just want to make sure you know this. Okay, when we're looking at precision, what you're looking at is, are you getting the same results every time? Okay, we're not looking at if the results are good or bad. We're looking at, are you getting the same result? So let's look at these here. Do you see these little dots? And this is our bullseye thing. Do you see you're not really getting the same results? They're kind of all over the place. Okay. Now do you see here? Now look at the dots there. Do you see they're all pretty much in the same spot? This is good. This is very precise. Even right here, do you see that all the dots are in a very similar position? It's good precision. And then over here, they're kind of all over the place a little bit, so it's not as precise. So precision, we're looking at, are we hitting the same number every time? Again, we're not looking at the number is good or bad, but are you getting, the same result every time? Now, let's look at accuracy. Accuracy means, are you getting the correct result? Okay, it doesn't matter the precision, it matters is, are you getting the result that's correct, So if we look over here, now let's say the bullseye right in the middle is the result we're trying to get. Now, are these accurate? No, they're not accurate at all because they're not even close to the bullseye. Are these accurate? Yeah, they're right on the bullseye. These are very accurate. What about these? Are these accurate? No, because it's not the bullseye. Are these accurate? Now this is a weird one. They're not on the bullseye, but let's average these, okay? If I averaged those two and these two all together, it'd be right in the middle. So do you see here it says the mean is accurate. So the individual numbers are not accurate, but the average of them is accurate. So it's just something that could come up. Anyway, so if we look at this one here, this one is precise and accurate. So you're accurate because you're getting the bullseye, and you're precise because they're all hitting the bullseye. Okay, so you can be precisely wrong, right? So that would be over here. So not over here, sorry, over here. So that's very precise, but very not accurate, okay? So if I draw a bullseye on here, another way of showing precisely wrong would be something like this. Here's my bullseye, circle, okay, sorry, I'm not very good at drawing, something like that. Now let me get a different color, something that would stand out a little better, pink, okay? These are my dots. Now what if I am doing darts, okay, and I do this, here, 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 I keep getting them over here, okay? Is that accurate? No, I'm not even close to the bullseye, but are those precise? Yep. Because they're all hitting, pretty much the same spot. Okay, so that would be precisely wrong. Now let's think about this. Let's think of terms of not necessarily bullseye, but we want to decide. We need to decide if somebody needs open heart surgery. Okay, so we need to do a test on them. Now, do we want this test to be accurate? Yes. Do we want it to be precise? Absolutely. So, like, when we're looking medically, we need something that's very precise and very accurate. We don't want the mean accuracy. We want the numbers exactly to be accurate. Anyway, so I just want you to know the difference between precision and accuracy. Again, accuracy is getting the actual correct number, and precision is getting the same result, good or bad, because you can get, the bad result over and over and over again, and that's precision. It's just precisely wrong. You really want to be precisely right.